The problem that I have developed is I like to call the painted cube. With this, there are about 3 or 4 different kind of smaller problems. So with this, each student should understand the problem, develop a plan, carry out the plan, and verify their solution with this. What you'll notice is as we go, we're kind of ramping up the problem-solving difficulty with these problems as far as the cubes getting larger and trying to make generalizations with it. Going into this, some vocabulary they have to know is what a cube is and what a face of a cube is, and know the difference of it. So the first question is, Susie wants to make a cube of wood for math class. She decides to paint the whole outside of the cube. What is the total number of faces that Susie painted? Some students, if they have difficulty with this, I have them also make a sketch. With some of the students, if they aren't able to make a sketch, they can grab different cubes, rectangular prisms throughout the classroom and make the same, hopefully correct, count that there are 6 faces. Like I said, with 7th graders by now, they should know what a face is, and the overwhelming majority of them usually realize that there are 6 faces on a cube. So the next part of the question, what I would call question 2, is as Susie's teacher decided to cut the smaller cube into cubes along the lines shown. After the teacher makes the cuts, how many small cubes are there? We go from talking about faces and, in a sense, surface area up here to more volume. And as 7th graders, they should know that to find the volume of a cube or a rectangular prism is multiply the 3 dimensions, and they get a total of 27 cubes. At this point, the next step is, after the teacher finished cutting the cube and placed it on the desk, a student bumped into the desk, which scattered the cubes across the desk. Because of what happened, the teacher asked these questions. How many of the small cubes have exactly 6 faces painted? How many of them have exactly 5 faces? How many of them have 4 faces, 3 faces, 2 faces? And how many of them have no paint on them at all? The reason why I had them calculate the volume on the previous page was hopefully they realize that this is the total number of cubes in this big cube. If they have this answer incorrect, then it is going to have a ripple effect down the line. So at a certain point, you could have a checklist here, have students check with their neighbor to see if their answers make sense. They could have them actually build this to reinforce the fact that there are only 27. With finding out how many have 6 faces, 5 faces, 4, 3, 2, 1, and 0, there's many different options to this. I usually don't start with how many have 6 faces, how many have 5, how many have 4. I start with the one where it has 1. And if you look carefully where these are located, they are in the center of each face of this cube. And there's 1 per face, and there are 6 faces, so there would be 6 total. To find out how many have 2 faces painted, it's the ones that are sort of in the middle of each side. If we look at the front, there are 4 on the front, there would be 4 on the back, and there turns out to be 4 throughout the middle for a grand total of 12. If the students mark up the cube carefully, they're going to notice that we're starting to run out of cubes. But on every corner, there's a cube that has 3 faces that are painted. I know there are only 7 shown here, but there would be 1 hiding in the lower back corner, for a grand total of 8. Looking at the picture, we notice that all the cubes are marked up, so therefore none can have 6, none can have 5, and none can have 4. There is only 1 cube left, and that's in the direct middle, the exact middle of this. There are 1, and if we total those up, we get a total of 27. It's important that students realize that these two numbers should match up, because that means we didn't add in any extra cubes and we didn't take any away. Upon completion of this, hopefully students realize that, okay, maybe there's a pattern. Is it always 1? Is it always the middle portion? Well, one way to see their level of understanding is to take it to the next level. What I mean by that is, instead of just having a 3 by 3 cube, now we have a 4 by 4 by 4. And if you wanted to go, you could go 5 by 5 by 5, 6 by 6 by 6, all the way up to n by n by n. As 7th grade, they might have difficulty going to the abstract nature of just a generalized form of it, but if you adapted this to a 8th, 9th, or 10th grade curriculum, you could push them to that level. They should know and hopefully calculate correctly that there are 64 total cubes in this larger cube. Should realize that the maximum number of faces that can be painted at any given time are 3. So 6 faces, 5 faces, and 4 faces would be 0. If we look back at our picture, we once again find that there are 8 cubes that have 3 sides or 3 faces painted. These are the vertices. If we look at how many have 2 faces painted this time, it turns out that there are 8 on the front, there would be 8 on the back, and as you go around the middle this time, there are 8 more, so you have 3 times 8, which is 24. And this time, there are 4 on each face that have exactly 1 painted. 4 times 6 is 24, since there are 6 faces. If we add these up, we get 56, so that means for no faces at all, there are 8 that are left over out of the total of 64. And it forms a 2 by 2 by 2 cube directly in the middle. It's difficult to see unless you had a cube that you could pull apart. Like I said, this was done with the 7th grade. Some of them had a little difficulty going up to the larger, but depending upon your students' abilities, you would be able to adapt this as needed and maybe even go up to a 5 by 5 by 5 if needed. Thank you.